In this video, we're going to talk about reactions that we can do with alkenes. But first, let's take a look at how we can make an alkene. So this is methyl cyclohexene, or 1-methylcyclohexene, and two ways that we learned to make an alkene. One, the first way we learned was using a strong base like NaNH2, and it will basically pull a hydrogen off of a carbon that's adjacent to a leaving group, and that will allow the electrons to collapse in from the hydrogen. Bromine leaves, and you get your double bond. The other way we just learned about was called a Diels-Alder reaction, which basically is a concerted mechanism where you end up with a single double bond. That sounded oxymoronic, but you have one double bond when you originally had three. You get connections that form, allowing you to make a ring. So those are the ways we can make the alkene. Now we have a bunch of reactions that we can do to an alkene. So we'll start here. When we add HCl, it's called hydrohalogenation. Basically, you're just putting a halogen on the more substituted carbon. If we wanted to go, and that follows Markovnikov's rule, if we wanted to go anti-Markovnikov, we just have to add some peroxide to the reaction and we'll put it on in an anti-Markovnikov fashion. We want to add an alcohol substituent to the more substituted carbon. We would do acid catalyzed hydration, and that would add the OH in a Markovnikov fashion. If we wanted to do it in an anti-Markovnikov fashion, we do hydroboration oxidation, and that would put it over here. Another reaction we learned about was just halogenation. So when you add like Br2 or Cl2, make sure you recognize that it's an anti-addition, meaning opposite sides it will add to. You get two halogens added. We could also, if you add a halogen in the presence of water, we get a halohydrin formation. So we get an alcohol and a halogen adding. Going to the other side, we learned about mercuration, demercuration. So we can do that with water or with an alcohol, and depending on which you add, it will add to the more substituted carbon. If you use water, it's going to make an alcohol. If you use an alcohol, it will make an ether. Another thing we can do is just reduce it with hydrogen, and that will get rid of the double bond. And we can also produce an epoxy by adding a per acid, and that will give us an epoxy bond right there. If we add, and we can also oxidize it in other ways, including adding KMnO4 cold. You could also use OSO4 for the same reaction. And basically you get a diol, meaning two alcohols, and it is a syn addition, meaning they're going to be on the same side of the double bond. Another reaction we learned about was ozonolysis. So the next couple reactions we're going to learn about break the double bond. Okay, so when you use ozone in the presence of a metal or reducing and somewhat reductive environment, it'll break it, but it will, where it splits the double bond, you're going to get, if it's a terminal carbon, you're not going to get an acid, you're just going to get an alcohol. I'm sorry, an aldehyde. And then if you were to oxidize it with KMnO4 hot in the presence of acid, or if you were to use ozone in the presence of peroxide, you will break the double bond, and instead of it just going to an aldehyde at the terminal carbon, it goes all the way to an acid. So these are just some of the reactions that we've learned so far, and we're going to have to learn how to use them in some fun synthesis problems on your quiz.